A quick context for anyone landing here without watching video two-way. So this lab is agentic-lab, a monorepo of small agentic AI demos. Now, my previous video covered the public repo guardrails. So Git ignore design, the Claude code hook, and one Git flag that closes a defense gap most repos would miss. Link in the description if you want that story. Now, this video is about the rest of the engineering. Public versus private project notes, the thinking around Docker, testing philosophy that fits in LLM app, CI as the gate, and some lessons I picked up from reading the Dependabot wall over a couple of weeks. Now, section 1 would be public versus private notes. So I'm going to go straight to this .claude folder. Now, I've touched on this pattern before, similar asset types with a public version and a private version. Project memory for the Claude code is a good example here. This file, CLAUDE.md. Now, there is a public version, which I'm committing to the repo, which is CLAUDE.md. There is also a private version. I'll firstly talk about the public version. This contains safe to publish things, how the toolchain works, the linting, the type rules, your commit conventions, etc. Then there is CLAUDE.local.md. This one has a similar purpose, but its audience is just me. This one is Git ignored. It holds the personal context, how I think about this project right now, what I'm stuck on, what's in flight, the stuff future me wants when I sit down again and that nobody else probably needs to read. A rule of the thumb here is simple. If a future reader would need to make sense of the code, it goes into the public one. And if it's just present me talking to future me, it goes in the local one. Section 2, Docker for isolation, design only. So caveat first, I have not written the Docker setup yet. There is no compose.yaml to show you. I will record a follow-up showing the running containers once the file exists. However, the plan is straightforward, at least in my head. The app is a pure OpenAI compatible client. It does not bundle a model. It does not run a model. It talks to whatever endpoint an environment variable points it to. So I could be using Obama or Llama, and not Obama, or Llama locally, LM Studio locally, or it could be a hosted OpenAI compatible endpoint, whether I'm using Bedrock or Vertex AI, whatever their new name is. So irrespective of those choices, I'll be able to simply point it to an endpoint, and that should be it. Now that choice does two things. One, app stays small, the Docker image in the app plus Python plus the dependencies, nothing else. Two, the model is a runtime choice. It's not a code choice. So that keeps the demo clear about what the code does versus what the model does. The compose file, when I write it, it will run one service, and it might evolve over a period of time. So it will have the app. The model is an external service that app will dial out to. Configuration being environment variable, I'm basically trying to base it on 12-factor principles as much as possible. I will demo that, the running container, in a later video. From here, I think, so tests, okay, of sorts. So right now there is one smoke test, a placeholder that asserts basically true. I'm going to go to this and test smoke. The point here is that the test suite is non-empty. So the CI job that runs PyTest has a surface to act on early on. So I just want to get into the good habit of doing that. Philosophy, I'm going to apply once feature code arrives. Now, LLM apps, they don't work with unit testing, or they break unit testing in a specific way. The model is non-deterministic, so you can't assert on its output. So a naive thing I might do is to run the model in a unit test and assert that response assert that the response contains some string. That would be flaky test waiting to happen. So it will pass maybe a couple of times and fail like other times for no good reason. And eventually, what it will do is that I will not trust the test suite and I will start ignoring the red bells. Really bad practice. So I'm going to do three things instead. One, the deterministic part gets real unit tests. The parser that reads a tool called the schema validation retry logic. The prompt loader, anything that has a function and returns value and behaves the same way every time. Two, so the orchestration logic, the bit that says give a model response, then do X and then Z, gets tested by mocking the model. So basically, you handcraft the model response, you call the orchestration, you check that it did the right thing. So model it's fake, and the test will be deterministic. Third is the actual model behavior. And so this bit is going to be non-deterministic, and this has to go into a separate eval set. So not in the unit test suite, it will run on a schedule or before release or when I want to check whether changing the prompt or model broke something or any other adverse effects. So it has its own assertions, or at least that's what the intention is, and its own tolerance, and it would have its own pass criteria. Wanted to touch on the layering, so unit tests for what is testable, mocks for what is orchestratable, evals for what is non-deterministic, and three layers, basically three jobs. Section for CI and hygiene. Let's go to ci.yml here. So CI has three jobs here. If you just focus on the name part, as you can see, and again, the code is publicly accessible. So first is lint and format, runs the pre-commit config that I mentioned in video 2a. Same checks locally and in CI, zero drifts between them. Now, second is your types and tests. So it will install the packages with dev-deps, run mypy across the whole tree in strict mode. Runs PyTest, and if either fails, the build will fail. Last but not the least, so security banded for deeper static analysis, plus a full history git leaks scan, set to fetch every commit in the repo and check the log, not just the diff, full history. And the reason for full history is that if I've committed a secret and fixed 3 commits later, it's still in the history, and the only way to know the repo is clean is to scan all of it. So that is what this job does. I'm gonna go to Dependabot from here. And so Dependabot watches both pip dependencies and GitHub actions weekly. So the supply chain stays current without me having to remember. And I am going to go to the terminal and git log one and grep dips, right? And as you can see, it's done its job. So a bunch of weekly runs, bunch of PRs raised and merged with another batch of, I think, 5 or 6 sitting as I record this. Plus like one foundation pin fix of my own. So this is what basically weekly scan looks like, and when it's actually wired up. And from here, now, what did I learn from Dependabot wall that I initially mentioned? So one, red does not mean that the bump is bad. The first time this happened, 3 of the original 6 PRs, they were showing failed checks. So the cause was not actually the dependency, the base was stale. It was sitting before the package fixes in commit. So in the relevant commit, and then the tell on the PR page is the tell on the PR page was the whole UI actually broadcasting that, but also if you were to do it through API, merge state status is equal to behind is how you can look for that. So rebased it onto the fixed space, and they basically went green without touching them. So here I'm on PR17, the same issue that I mentioned before. So banded bump in this open batch, it's sitting behind right now as I record this. So same pattern, same fix. It just needs to be rebased with the current main, and it will go green. Two, there is a class of pin Dependabot structurally can't see. So I'm going to go to the terminal for that and git show 3a7814 pi project.toml grep pi test. And so as you can see, the project had pi test 8, greater than or equal to 8, and but less than 9. So stable, latest stable was 9 or 3. But the less than 9 cap excluded it. And Dependabot does not widen an exclusion. So it never raised a PR for that. I later found out about this, and it got fixed in PR12 alongside like a bunch of other stale but in-range flows for UVCon and pydentic settings. So listen, a tool catches what they are shaped to catch. You will still need to have other ways to audit the caps. I think the third one, yep. So there's a really big gap. So while I can capture and I can work on known CVEs, there is no current way to deal with malicious releases. So when I ran an OSV scan before pinning, it was clean. A few weeks on, the same audit no longer comes back clean. There were a handful of packages got picked up as new CVEs since pinning, and the count basically keeps on growing as new advisories land. So the drift is itself the data. So CV scanners are a moving baseline. The same scan can flip from clean to non-clean week to week. I think most of us have seen that with Docker images and a whole bunch of other like Node.js modules, Ruby modules. So the harder gap, however, while I'm complaining about that, harder gap is what CV scanners will still miss entirely. So this year, like bunch of real malicious PyPy releases like PyTorch, Lightning, Light LLM, and Intercom Client, where bad versions were live and were being installed before before anyone caught it, ahead of any advisory. So a CV-only scan checks against what is already published. So a freshly poisoned release can still slip straight past it. Now, I might cover the gap in the next video and like some pros and cons of like really pinning the hash over perhaps like pinning the versions, semantic versions. However, this repo, the point I'm trying to make is this repo does not have a malicious release scanner wired up yet. And I am aware that this is a lab repo, and I am trying to pretend like it's production just so that I can like just get into the habit of doing that. And also it's just a good practice. From here, I think I'll just quickly go to two other things that I have not talked about a lot in the past. MIT license and security. So security.md, this is pointing to GitHub's private vulnerability reporting. I know, I'm aware, I'm wearing the t-shirt of GitLab while I'm doing all of my work on GitHub. That's a video for some other day. So I've cared like less about license and security reporting and all of that because normally if it's sensitive enough, I would generally keep it private. But I'm learning that projects like this, it's just just a good practice to get into the habit of. So I'm basically putting the instructions out there as to how to report, and also just some licensing detail. Again, might be an overkill for lab. So from here, I am going to go to README. I guess again, like just trying to keep a bit of a standard here. So basically 5 batches at the top. CI build, MIT license, Python version, rough pre-commit. And then there's a status table. It basically talks about what exists and what is planned. So this is all foundation, like I said. Everything I just showed is committed. Code is what's missing and what comes next. Now, one thing I've not done yet, might do later. So hash pinning the dependencies and the pinning of the Docker base image to a digest. So today I don't see the value in that because again, code has to be there. I guess that would be it. So if your engineering looks different to mine, let me know. I am going to put the repo link in the description and hopefully we'll work on the next video sometime soon and with a demo. Thanks for your time. Later.